Okay, so today we're going to look at section 3.1, reflections. These are a rigid motion. Let's start by defining what a rigid motion is. It's a transformation that preserves length and angle measure. So a reflection basically is we're going to reflect something across a line. Kind of just think of it about if I placed a mirror at a line, what would some geometric shape look like in the mirror? So that is what basically what a reflection is. Here is the full definition that we're going to look at and some properties that we're going to explore. What is a reflection? It is a transformation, a change that reflects each point in a pre-image. That would be the A, the B, and the C would be the A pre-image across a line of reflection, which is the line M, okay, producing this reflection, A prime, B prime, C prime, okay? It has these properties. So if a point is on the line M, then the point and its image are the same point. And so I use that example right here. Point A is on the line of reflection. So A and A prime are the exact same point. If it's not, then it follows into the same pattern as all the rest. If a point is not on the line, B, and the line M is a perpendicular bisector of the segment from B to B prime. So it would be perpendicular, that segment, and it will bisect it. And that's the same for all. The reflection of ABC across line M. So when we write a reflection, we use a capital R. The subscript down here is the line of reflection. So in this case, the line is called M. If it was an equation that I knew, like x equals 1, then I would write x equals 1 down there. Of the triangle ABC is the triangle A prime, B prime, C prime. So that's how you would write the reflection rule. And then again, a reflection is a rigid motion. That means as I do a reflection, the length of all the sides, the angles are all preserved, nothing changes. Okay, so this is a reflection. And so what we're going to do now is we're going to do an example here, how I can use constructions and how you're going to use constructions to draw the reflection of a triangle LMN across a line L. So here is our example. I want to draw the reflection of this across this line. So imagine a mirror right here. What would the reflection look like? Okay, and so we're going to use our compass and stuff, and we're going to use the knowledge that we had of the properties, okay, which says basically that if I connect M with M prime, then this line is going to be a perpendicular bisector to it. So what we're going to do is we're going to draw a perpendicular line to line L that goes through the point M. In fact, we're going to do that for all of those. Okay, and so I'm going to show you how we do that. If you don't remember, piece of paper, please. So perpendicular through a point. I need the point, and I need to be able to make some marks over here on the line itself. Nice small marks. We don't need big marks. We're going to have a lot here. And what that does is gives me two sections here that I can then draw a perpendicular bisector with. Okay? And it will go through that point right there because we base those two marks off of that point. So we come over here. We want to make sure we're more than halfway. And we make a mark up here. Do the same thing from the other direction. And then we connect those two dots. Now, since I don't know where the M prime is going to be, I'm going to extend this out just a little bit because I don't know where the dot's going to land up. It's not necessarily going to be there. Okay? And we can do this to all of these things, to draw all of those lines, and then we can do and find where the new points are going to be. So let's do N. There and there. And then come over here, and that'll work well. So I'll do a mark down here. Hopefully you guys can see what I'm doing. And I can do a mark up there. And so we'll draw a perpendicular for N. So somewhere on that line is going to be N prime. And then one more time we'll do for L. So we need to make sure we can mark points on these lines. And then we come out here and we do it from there. So those are all the perpendiculars from the corners, the vertices of my triangle. Okay, so now the next part is to figure out exactly where these new image points are going to occur. And what you do there is you just simply do a copy of segment. So we're going to put and copy this segment length. So that's where it is there. Then I can take this and say, do the same spot over here, put a mark right there, and that mark right there is M prime. The same distance, because remember it had to be a perpendicular bisector, so it had to bisect it. So we drew the perpendicular, and now I'm doing the same measurement, and that's the bisecting action. We can do N. Measure that distance, and then measure the distance again. So there is N prime. And then measure L. Landed right on it. And that's L prime. And so then I can take my straight edge and I can draw this triangle. And that is how you construct a reflection. So if I took a mirror here and did the reflection in the mirror, this is the shape I would see. Okay? So that's how you would do that. And then you can name this transformation. This is a reflection of line L of the triangle LMN, and it will produce the image triangle L prime, N prime, N prime. And that's how you would write it. Okay. So there it is right there, and it's in the directions of what I talked about right there. All right. So let's look at it here. Some other things that we want to make sure we're aware of. Because it's not all going to be constructions. You're also going to have things in a point in an XY coordinate system. So what is a reflection if the x-axis or the y-axis is the reflected line? Okay. So what does a point do? What does it change to? So any point in a coordinate system that's reflected across the x-axis changes the coordinates to this. So the x will stay the same and the y becomes the opposite. Because remember, you're going over the x-axis. So the x's will stay in the same spot, but the y will change signs. And likewise, if I have a point and I'm reflected across the y-axis, the y will stay the same, but the x will change signs to a negative value. Okay, this means the opposite. So if it was over here as a negative, when I reflect it, it becomes positive, and vice versa. So there's the reflection across the x and the y axis that we need to know. Okay, so let's look at an example of how that's done. So down here I have two examples. We're going to reflect this one across the x-axis and this one across the y-axis. So we'll do one at a time so you can see it. Then I'll show you how it all matches up our definitions. So if this is point, we'll start with point B. If B is 1, negative 2, and I'm going to reflect across the x-axis. So this is my reflection line right here, okay, the x-axis. Then what we learned is the x will stay the same, but the y will change sign. So it's going to come up here to 1, positive 2. So you can see it's a lot easier here in a grid system than it is to constructions. So this would be B prime, and it would be 1, positive 2. Here is negative 3, negative 4. So when I reflect that over, it's going to stay at negative 3, but it's going to come up here to positive 4. And so we'll have a dot right there. And that dot becomes C prime, which is negative 3, positive 4. And then this one's going to stay at negative 5, but drop all the way down here to negative 6, 2, 3, 4, 5, 6, and all the way over here to 5. Right there. And so then this is A prime, which is at negative 5, negative 6. And then I can draw this new triangle, which will be the reflection of the other one. And that's the reflection across. And if I did this right here, you will notice that the x-axis becomes a perpendicular bisector of all of these points. And I can do it for all of them. It's the same distance on both sides of the x-axis, and they are perpendicular to the x-axis. Okay, so if I do this one over here, I'm reflecting across the y-axis. So the y value will stay the same, but the x will change sign. So this point A becomes positive 5, 6, and then up to 6. So this point right here will become A prime, 5, 6. 1, negative 2 becomes negative 1, negative 2. And this point right here comes over to here at negative 3, positive 4. Oh, sorry. I reversed that in my brain. I meant positive 3, negative 4. Okay? And then we can connect those and have our reflection lines. So there's the reflection across the y-axis. And again, if I drew dotted lines here, you'll see that they all lined up. And this is a perpendicular bisector. The y-axis is the perpendicular bisector. So this is what you kind of do on the grid system. You just make sure you know how to move things around. And so let's look at another example that I have here. Okay. This is the last example that I have for this. Questions that you'll be doing on tests and things like that. In this case, what is the reflection rule that maps the triangle to its image? So in other words, if this are the points of the triangle ABC, and this is the points of this image, A prime, B prime, C prime, then I need to know the rule that produced that, okay? And so let's talk about this. So how would I do this problem? Well, first off, I need to draw these triangles and label them. So I need to figure out where is 7, 6, and all that kind of stuff. So 0. So A is 7, 6. 1, 2, 3, 4, 5, 6, 7, and then up to 6. 2, 3, 4, 5, 6. So right about there. This is A, 7, 6. The next point is 0, negative 4. So this right here is B at 0, negative 4. And then C is at negative 5, 0. So this is C at negative 5, 0. So that is the one triangle. This is our pre-image triangle, the triangle that I start with. And it can be any shape. I'm just using triangles so I don't have more sides to deal with. I could have done it with other, but it's better to see it as a triangle. All right. So then I'm going to graph these points on the same system so I can see what the reflection would look like. So -5, 6. And so I have to come up here to 6 and to go to -5. That's A prime. And then 2, -4. So that's B prime. And then 7, 0. 3, 4, 5, 6, 7, 0. That's C prime. And so let's draw that one. Okay, so there's the two triangles. All right, and so we need to find the rule. Well, the rule has the reflection, and then I have a line of reflection, so the reflection line. So clearly that's the thing I don't know. I don't know the reflection line. I got to find the reflection line from this picture. So what do I know from the properties? Well, I know that the reflection line is a perpendicular bisector between these points. So if I drew a dotted line between these points, I know, and then this is another one, I know that the reflection line is a perpendicular bisector. So how do I find that? Well, I need to find the midpoint of each of these things. And you can find the midpoint by simply using the midpoint formula or whatever it is. If you're on a grid system, it's going to be popping out pretty obvious where it's at. The midpoint here, the distance between here and here is 2, so the midpoint's at 1. So that's the midpoint. Where's halfway between these two numbers? In this case, it's pretty straightforward. It's basically right here at 1 again. So we can see that the line is going to be at 1. So if I draw the reflection line here, this is my reflection line. We're going to call it L. But I also know the equation because it's a vertical line. I know that it's x equals 1. It could be more challenging to figure it out, especially if it's at a diagonal and things like that. So I'm going to go through this as if it wasn't nice and neat. But for right now, once I have this equation, I can write the rule. It is the reflection across x equals 1 of the triangle ABC and produces the image A prime, B prime, C prime. Okay? So that's one way to do it. So you can always find that equation. Sometimes it'll be hard, especially like I said, if it's a diagonal, it might be very challenging to figure out that angle, stuff like that. So what is another way I can do this? And there's also an alternative method for writing this rule. So this is the reflection notation, but how do I find the rule as a point notation? So in other words, what do I do to that point to get that point? And you'll see both forms of this in standardized tests and things like this. Sometimes you'll see this notation, and sometimes you'll see the next thing. So the rule I need to figure out is, how do I take this point, this XY point, and get this XY point? And that rule has to be the same for both, for all of them. So what I need to do is I need to find the rule to get a new X. So we're going to look at this as, here's a point in the X, and we're going to put all our data into a table. This is the image point of X. We have 3 points here that have X's. The 7 becomes a -5. For B, the 0 becomes a 2. And for C, -5 becomes 7. Okay? So that's the rule for the X's. So what pattern do you notice? What do we see here? Well, we see that as I add 7 here. I'm subtracting 7 here. As I add 5 here, I'm subtracting 5 here. So my rate of change, so my change from this is -1. Because that's consistent all the way across, then I know this follows a linear pattern. Okay? And then I can find a rule for this, just like we would if this was a normal table of values. What is the rule for this? That is my common difference right there, my slope. Okay? This is my 0 number. We always want, if you have the 0 number, you always want it. If I didn't, I could have chosen any point. So then I know what? I can get a new value by taking the second value. So we basically this minus that, and then we subtract the -1. So there's the -1, the t, and then here's the original value minus 0. So that's the point. And so what it tells me is this. As I distribute the negative sign and do all this kind of stuff, that if I take 2 and subtract the original x value, I'm going to get the new value. Take 2 and subtract 7. There you go. Take 2 and subtract -5. So 2 minus a -5 is 7. Take 2 and subtract 0. 2. So this is my new rule, which I can then change to 2 minus x. And so then they would write the other rule in this fashion. Take an x and a y, changes, the x becomes 2 minus x. Whatever the x is, take 2 minus that number and you'll get the new x. Now, is there any change in the y values? So 6 went to 6, 0 to 0, -4, -4. No change in the y values, so the y values will stay the same. So this is another method to show this reflection. This is a point change. How does every point change? Or I can do it as a reflection across the line, x equals 1. Both of these are the same rule, just written in a different fashion for a different purpose, but that's how that works. And so let me go ahead and show you the original notes so you guys want to copy these things down. So that was the original one I had up there, the first example. Okay, and then here's the one I just did. And I'll let you pause here and you can copy that down if you want to, the work I went through. Okay, and so that is reflections. We're going to be doing all 3 of these things. We're going to be doing changes, finding reflection lines, using reflection across x and y axis, and we're going to be doing a construction technique for reflections. Okay, and so that ends this video. We'll talk more in class.